All right, so this is reassessment video for Newton's second law, and I'm going to show you that this is the scenario we're talking about. This is a magnet right here, and the crane arm, and it would be used to pick up scrap metal or even large pieces of metal in a junkyard or something. So our scenario asks, it says 250. I'm going to go ahead and do this back on my drawing. A 250 kilogram magnet is being used to collect metal from a construction site. The magnet dangles by a 2.4 meter chain from the end of a crane arm. The crane arm accelerates to the right, this way, such that the magnet swings back 13 degrees that way. And we want to determine the acceleration of the crane arm right here. That it's the same thing as the acceleration of the magnet. And then what is the tension of the chain that connects the magnet and the crane arm right here. All right, so first thing we're going to do is draw our forces, free body forces. Can you see that? All right. And we'll get a little clearer. There we go. All right. Oh, shoot. Okay, so we have our x-axis and our y. We have our gravitational force. I'm going to keep this image here. Okay. We have our gravitational force going downwards, and I went ahead and figured that out because we do know our mass and we know our gravity that is negative 9.8 meters per second squared. Our mass is 250 kilograms, and we get a negative 2,450 newtons because kilogram times meter per second squared is newtons. All right, now Newton's second law says that the summation of the forces on an object is equal to the mass times the acceleration of the object. All right, so first let's set up our equations. Set up our equations to find out the forces on the x-axis and then the y-axis. First of all, we can use this Newton's law right here to help us determine some things. Okay, so we'll say the summation of the forces, on the y, and we can see, okay, all right, we can see on the y-axis that the forces on the y are going to equal 0, right? Okay, so we can just say equals 0 right here. And if we know that the summation of the y is 0, that can tell us something, because the summation of the forces on the y-axis and the summation of the forces on the x-axis is equal to the sum of all forces, right? And that, we said, Newton's law is equal to mass times acceleration of that. So, deductive reasoning, we can say that the summation of the forces on the x, that's 0, so it equals mass times acceleration like that. All right, so now let's come down here and say, okay, I already wrote it. So on the y-axis, right here, all right, oops, sorry. On the y, we can set it equal to 0, and we have tension force. In our free body, oh yeah, I didn't mention, in our free body, we have our gravitational force going down, and then, of course, we have the tension of the string, which was right here, of the rope. That's going up. And I called it F sub T. F sub T. All right, and then that's our angle theta now. And now we want a cosine of that. So if we're talking about the y-axis, let's go ahead and say 0 equals our force of tension cosine theta minus the gravity. So rearranging that, we can find the tension force equals 2,514.4 newtons. Then in the way of the x-axis, the summation, we set it equal to the mass times the acceleration of x. Right, okay, so now we want to use sine because we used cosine for the others, so this time we're going to use sine for the x. And we know our tension force, so we just plug it in there, solve for the acceleration, and we come out to 2.26 meters per second squared.